the last video we introduced the counting rules, and so now we're going to look at three basic experiments where we use our counting rules that you'll see over and over and over again. The first one of those is flipping a fair coin. Alright, so that's the first experiment we're going to look at, is flipping a fair coin. Alright, so that's what this video is all about. Alright, so our experiment, we want to so we want to list the set of outcomes and count the number of outcomes. Alright, we want to have how many and what are they. Alright, for this one. And for all of these are all going to be universal set types. Now I'll talk about subsets, but when we list them out, it's easier to find subsets. Alright, so the first experiment, part A, is, well, what if I have a fair coin and I toss it one time? Alright, so my universal S would be how many ways how many outcomes do I have when I toss a fair coin twice? Well, there's just two, right? We list them as either heads, right? A fair coin has heads on one side, tails on the other. Now, for the coin examples, we're going to shorten. Again, mathematicians, we like to shorten things. Right, the same thing is true going to be here. All right, whenever I have heads, I'm going to say capital H, and whenever I use tails, I'm going to use capital T. All right, so there's my set of outcomes, right, my two possible outcomes when I flip a fair coin twice. And so a single event would be, getting heads or getting tails. So heads would be an element of this outcome, and tails would be an element of this outcome. All right, the second experiment, we still have a fair coin, but this time we're going to toss it two times. Alright, so there's two parts to this experiment. This is the Cartesian product rule we're going to see here. I'm going to pair my two tosses together. Alright, so my experiment is I've got my first toss and all of its outcomes paired with my second toss and all of its outcomes. Well, the Cartesian product is the number of ways the first toss can happen times the number of ways the second toss can happen. Well, there's still a fair coin, right? Still tossing a fair coin, I'm just doing it twice. There's two possibilities on the first toss, and two possibilities still on the second toss, right? I get heads or tails on toss one, or I can get heads or tails on toss two. And so, multiply my 2 times 2 to get 4. So the total number in this experiment would be 4 total outcomes. 4 different outcomes if I toss a fair coin twice. Well, now I'm going to list them. Alright, remember when we have the Cartesian product as a pair, right? Two things are happening. My first outcome of my pair would be the first part of the experiment, which is my first toss, and the second part of my pair would be the second part of my experiment, which is my second toss. Alright, I'm going to list them as points like we did before. Alright, so one possibility is heads on the first, heads on the second. Another possibility is heads on the first, tails on the second. Or tails on the first, heads on the second. Or tails on both, first and second. And that's it. Those are all the possible outcomes if I toss a fair coin twice. Now, again, we like to shorthand things. We will often drop the parentheses, the pair look, and just write them like this to make it a little quicker. Alright, and so it's the same set, it's just written without the pair notation. So heads, still the order matters. First toss, second toss. First toss, second toss. First toss, second toss. And those are still my 4 outcomes, right? I've got 4 outcomes when I toss a fair coin twice. And eventually what we're doing, if we did a subset of this, it would be, if I toss a fair coin twice, how many ways are there to get exactly 2 tails? 1 out of 4. How many ways are there to get exactly 1 tail? 2 outcomes there, where I could get the 1 tail on the first toss or the 1 tail on the second toss. And so there'd be 2 possibilities in that subset. Alright, the last one from this example, still have my fair coin, but now I'm going to toss it 3 times. Alright, and I will set this one up when I go to list it as a tree. So this is going to be my example of using a decision tree. Alright, before I do though, it's still a Cartesian product, I just have one more set of outcomes. So I've got my first toss and all of its outcomes paired with my second toss and all of its outcomes paired with a third toss and all of its outcomes. Well, number of ways the first toss is still 2. Second toss also has 2 outcomes, and the third toss has 2 outcomes. And so it's 2 times 2 times 2, 2 cubed, or 8. And so the universal set would have 8 different outcomes. Now you might be able to list the 8 different outcomes without a tree, but this is just a really good experiment to practice. If you've never seen a decision tree before, when we will utilize them more, we utilize them a little bit in Chapter 6, but we do whole sets of problems with them in Chapter 7. So again, kind of just touch on them here, but will help us out for the next set. Alright, so what a decision tree does is it's just an easier way to organize my information. Alright, so I have my first toss. And so a tree is branches, right? I branch out on all possible outcomes. Well, there's 2 outcomes. I can either get, on my first toss, it can come out heads, or my first toss can come out tails. And one of those 2 things are going to happen. I don't know which one will happen, but one of those 2 will happen. Alright, and then I have my second toss. It also has 2 possible outcomes, but my branches are going to stem from what happened on the first outcome. Alright, so I've got heads here. Well, the second toss could come out heads or tails again. And same thing down here. If I toss tails on the first one, my second toss could come out heads or tails. And so I've got 4 sets of branches when I have 2 tosses. And if we look at this, this is the sample space for the last one. I only have 2 tosses. All right, if you look at it, it's heads, 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 tails, tails, heads, tails, tails. All right, but remember we were doing a third toss. And so now at the end of each of my second toss branches, there's 2 more branches that come out because there's 2 possibilities after each one of those. And I get heads, tails on each one of those set of branches. And then I'm going to list my outcomes. And I know there should be 8. And basically it's just reading down the branches. And again, I'm going to not draw them as a point. I'm just going to list them in the order. And so it's going down my branch. So my first outcome is heads, heads, heads. Alright, so my first outcome is all 3 come out heads. My next one is heads first, heads second, then tails third. So heads, heads, tails, and then so on. Just make sure you read down the path. Alright, so the next one would be heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And then all 3 come out tails. A little sloppy there. But if you count them, these are all the possible outcomes. There should be 8 of them. Alright, and that would be my universal set. And then again, we're also going to have to count subsets of that. So there's all possible things that can happen when I toss a fair coin 3 times, right? Those are it. Those are all the possible things that can happen in my 3 with my 3 tosses. Alright, and eventually what we're going to do is we're going to find, and so the try on your own is a subset. Alright, so how many of these 8 have exactly 2 tails? Alright, count them and list them. So we want to find the number in my subset where I get 2 tails. Exactly. You know, I can't have 3 tails, I can't have 1 tail, I have to have 2 tails. And you go through and you count how many of them, it should be less than 8, how many of those 8 outcomes have 2 tails. Alright, then list them, and again I'll post the answers later. Alright, so that finishes up the example of flipping a fair coin. Alright, again, we're going to be using these experiments, so make sure you understood them, because you'll see them again and again and again. Eventually we'll do probability and statistics on them. Alright, we'll stop there.